Hi everyone, my name is Eric Notless. I'm a final year MD PhD student at the University of Michigan. This presentation is an adaptation of a brief chalk talk that I made for our residency prep course. I felt like the content might be widely applicable, so I made a video version. As you can probably tell, the title of the talk is a primer on artificial intelligence in medicine, or the things you should feel comfortable asking about as a physician. Note throughout this talk, I'll use artificial intelligence or AI and machine learning ML synonymously. So to start us off, there's a sort of big statistic that I like to start with. The FDA certified their 690-second AI model in 2023. And less than 5 years ago, there were actually only 73 models that had been certified. And this is actually just the tip of the iceberg. Most of the AI models that are currently deployed in healthcare systems are not actually certified by the FDA. It's not actually necessary to go through the certification process if a model is providing information for a physician to incorporate into their decision making. So many of the models that are currently being produced by vendors or for research do not need to go through certification. So we have a growing number of models, and the onus is actually on physicians to catch the bad ones. So the goal of this talk is not to make you an expert, to actually instead make you just comfortable asking some questions. So if you find that you're interacting with an AI model that is potentially new to you, you should feel comfortable asking 3 questions. The first one is, how is it made? Is it any good? And how is it being used? So first we'll jump into how is it made. Throughout the talk, I'll throw in some terms that you may see the engineers or developers use. So this phase of making a model is called development by engineers often. So the goal here is to estimate unknown information using known information. And the model is actually going to be the thing that we use to make this estimation. So to make a model, we're going to collect lots of data, and then we'll use some math and programming, the details of which we don't have time to go into, and oftentimes you don't actually need to deal with the nitty-gritty, but you do need to have a sense of where the data come from. Oftentimes the data that we're using is going to be collected in a retrospective manner because we need to know the status of unknown information. So we need time to have passed in order to actually observe this information. And engineers will refer to known data often as X, and then they'll refer to unknown data as Y. And so our model is going to sort of map X to Y, or estimate X from Y. So it's very important that we use the right information in making the model. And the clinical perspective is actually essential because accidental inclusion of information tied to the outcome of interest can reduce the utility of a model. So this is a toy example, but let's say we have a sepsis prediction model that uses information about fluid administration or antibiotic administration. Why might this be problematic? Well, these are markers of resuscitation. And if the model comes to depend on them, the alerts that we start to get from the model might actually just be too late because it's going to be looking for the markers of resuscitation, which the physician will have already started because they had already identified the patient was at risk of sepsis. So thus we have a decreased clinical utility of this model. That's a very extreme case, but there are studies that have shown evidence of models inadvertently relying on clinical markers that are tied to the outcome. And so we do have a lot of models that are out there that may not be providing as much clinical utility as the developers think they should. And it's up to us as physicians to sort of investigate and get to the bottom to make them better models. So this naturally brings us to the second question, which is, are the models any good? And this phase is often referred to as engineers as validation. So essentially validation seeks to test the model's performance on data it hasn't seen before. And the concepts that we're using for performance measurement should actually be pretty familiar to most physicians because it's closely related to concepts from evidence-based medicine and biostatistics. I'm sure you can think of some measures. Take a moment to think of some. Some that aren't on the slide include accuracy, PPV, NPV, NNT, the area under the receiver operating characteristic curve, and then also sensitivity and specificity. So why are we looking at data that the model hasn't seen before? And what are these types of data? Well, data that a model hasn't seen before are often either data that were explicitly held aside for testing and not used in the development of the model, or data that are seen in prospective usage of a model. And why do we assess on held aside data? Well, models, somewhat like humans, can actually start to memorize training data. And we call this overfitting, which means that a model that overfits is not going to tend to work well in new situations or won't generalize well to patients it hasn't seen before. In a related manner, you might want to actually understand what population this model works well on, because models made for one population may not work well for others. And models often optimize for the majority, and so you'll need to check the performance of models on vulnerable subpopulations. So you can see, as an example here on this slide, that your performance that you might have observed from the training set might be the highest. And then if you go and look at a held aside data set, it might be slightly lower. Prospective usage may be even lower still. And then vulnerable subpopulations may even be lower. So it's very important that this analysis is conducted in a thorough way in order to actually assess, are we doing well on the populations of interest? Finally, validation should actually happen multiple times. It should happen across the model development lifecycle and as the model is transitioned into clinical use, and then it should be continually validated throughout the course of its use in the clinical setting. Finally, the last question you should ask is, how is it being used? And this is tied to the concept of implementation. So developers often try to come up with ways to connect models to clinical workflows. And I'm sure you can think of a couple different ways that you may have a model integrate into your clinical workflows. Ultimately, the goal is to deliver information that's timely, clinically relevant, and to the right clinician. So one potential workflow that we might have is you may have a model that's generating risk scores. The data comes first from the EHR, then it gets computed into sort of the input variables, then it goes to the model, and then you get a score. The score then may get passed either back into electronic health record as a list of scores, or they may go directly to the physician. Or you might have alerts that come to you in the form of a page or a best practice alert. Oftentimes, developers don't actually know clinical workflows, inside and out like physicians do. So if you find yourself receiving alerts that don't add value, don't improve your medical decision making, or sort of, you feel like are breaking your task or interrupting you needlessly, you should feel empowered to ask for improvements. You are the clinical expert. You know what you need to know. The developers oftentimes do not. So, in summary, if you're concerned about a model or just even curious about it, you should feel comfortable asking 3 questions. How is it made? Is it any good? How is it being used? Every developer should be able to answer these questions or be able to share a paper that studies them in a very detailed manner. That's sort of the gold standard. Thank you very much for watching this. If you have any questions, feel free to email me. Email address is over here. And or just reach out to me via my website or Twitter/X. Thank you very much for your time.